Welcome back to Math for the Void. Math and algebra coming at you out of nowhere. We're in the Calc Prep assignment part 21, and we're going to take a look briefly at some complex fractions. Now, I should say this isn't going to be a huge deal in calculus. This is a bit of a skills exercise, but not something that is a core essential skill or any specific type of problem that will present like this in calculus. However, being familiar with how to work with expressions like this, not being intimidated by them, is really going to step up your abilities. Not only to check for important things, such as rational expressions with denominators which can be zero, or difference of squares factoring patterns, or when you can recognize a quadratic. But this is going to be something you can carry over to other situations where you do have these complex fractions arise occasionally. So let's talk about it. This looks pretty complicated. We have this expression, it's a binomial expression, but we have a fraction in it with x minus 1. Yuck. So we're going to probably want to fix that. Next, we see the same denominator on a fraction, but that fraction is already inside of a fraction. So this fraction is the denominator of this larger fraction. So already we have some complicated layering going on. The best way to simplify these things is not always immediately clear, but something that you can do to try and play with these kinds of objects is to work from the inside out. So what do I mean by that? Let's look at the layer inside of the layer. Here's a pretty significant fraction, but here's the fraction within the fraction. And here's something being subtracted from the fraction within a fraction. So let's work at that first. Let's take this x minus x squared over x minus 1 and see if you know what to do here to combine these together. We need to have the same denominator. So I'm going to multiply this x by x minus 1 over x minus 1. And now they have the same denominator. So if I distribute this along the top, I have x squared minus x squared. I can put everything together now over x minus 1, and this will give me a negative x due to the cancellation of those over x minus 1. So this already simplifies things quite a bit. That means this entire expression in the bottom can be rewritten as negative x over x minus 1. Now let's also do something here in this set of parentheses. We have another fraction being added to a number, being combined with a regular number. So let's do the same thing. I'll write it here on this diagram. I don't need to write it off to the side. X minus 1 plus 1 all over x minus 1. These will cancel. Interesting. So this gives us x over x minus 1. So how can we write this entire expression over in a nicer way? That means we basically have x over x minus 1 times 2 over negative x times x minus 1. And so if you think about this carefully, this is really like a fraction over a fraction. which results in x over x minus 1 times 2 over 1 times x minus 1 over negative x. See, that's because when we divide this by a fraction, it's the same as multiplying by its reciprocal. And the reason why that's pretty convenient is because the multiplication allows us to cancel anything on the top that's a factor with anything on the bottom. So the result of this, don't forget the negative, is simply negative 2. Very nice and easy. This entire expression just turns into negative 2. Who would have thought? Great, now let's work on this function here. Recognize that? I hope you recognize that this is a quadratic function. What can we do with quadratics? Well, we can find their maximums or minimums. In this case, we're just going to be plugging in some values. So we're going to plug in x equals negative 2. So that's going to give us negative 2 squared minus 2 times negative 2 minus 3. So overall, negative 2 squared is 4. Negative 2 times negative 2 is also 4, giving us 8 minus 3, or 5. Nice. Okay, that's easy. That's level 1. Level 2 is looking at this. Now this was the input of the function, so I used it as x. And again, this is the input of the function, so I'm going to use it as x. Now what is that going to look like when I plug that in? We're going to have x plus h squared minus 2 times x plus h minus 3. Now, do you have to simplify all that out? Not necessarily. Do I want you to? Yes, let's do it. X plus h squared. That's going to leave us with x squared. If you have to do the box method or FOIL or whatever you need to do, go for it. Plus 2x times h plus h squared. Great. Now we're going to distribute a negative 2. That's going to give us negative 2x, negative 2h, and then minus 3. So a long answer which has x's and h's in it because we plugged in x plus h. So it makes sense that there should be some x's and some h's in it, right? But here's where things get truly interesting. This, what we're looking at, is called a difference quotient. Very important term and phrase to use here. This is called a difference quotient. Why do we call it that? Well, let's look at the words that we're using. Difference means subtraction. Quotient means division. So we're basically going to be doing some subtraction and some division. See that? We're taking this, we're subtracting it, and then we're dividing by h. So let's just take a look at that. We've already done the f of x plus h. So when we expand all of that, we're going to end up with x squared plus 2xh plus h squared minus 2x minus 2h minus 3. That is my f of x plus h. Then we're going to subtract from that, I'll put it in round parentheses, the function f of x. So we're not plugging in anything, just rewriting it with x. Right, where's that original function at? Here it is. X squared minus 2x minus 3. But one thing you want to be very careful of, everybody, is that you need to make sure you have the parentheses there. Because you're going to have to distribute that negative. And then we're going to divide everything by h. You don't have to plug anything in, just leave h. Now what is the special tip that I'd like you to know? I'd like you to know the following info, which is that everything with an h must cancel. Okay, so everything on the top which does not have an h, I think I might have said that wrong earlier, so in case I said it wrong, let me rephrase it. Everything which does not have an h must cancel. And we're clued in about that because everything's going to be divided by h. So anything that doesn't have it will go away. For example, -3, if I distribute this, becomes +3, so it cancels. -2x, if I distribute this, is +2x, so it cancels. X squared, when I distribute this, is -x squared, so it cancels. See how everything that does not have an h is now gone. So this is going to leave us with 2xh plus h squared minus 2h all over h. Take the h's out. You can divide everything by h now. So this is 2x plus h minus 2. And now that those are canceled, our difference quotient is equal to 2x plus h minus 2. Really good practice for getting prepared of the algebra necessary for the first part of calculus. We're going to do one more like this with very similar questions, except the function is going to be different. It's not going to be quadratic. Here we have a rational function. And so the technique for doing the difference quotient is a little bit different. Let's give this a go. Given this function, which is a rational function, first we just want to find f of -4, which simply means plug in -4, right? This is the input, -4, input of the function. So this is going to give us 1 over -4 minus 5, or -1/9. You could also put 1 over -9. It's the same thing. Very simple there. We're really just putting a square block into a square hole and a round peg into a round hole. That's a big part that people miss in their algebra development, in their skills development. They lose sight because of all these letters of where things belong. This x plus h simply belongs in the input now. So everywhere I see an x, I'm going to write x plus h. This would be 1 over x plus h minus 5. Very simple. Now, if that's so simple, why am I having you do this exercise? Because the difference quotient is not so simple. The difference quotient is going to lead us to having fractions within fractions. Let's look at how. If we have f of x plus h, which we just did for part B, x plus h minus 5, but then minus f of x, which is just the original function, 1 over x minus 5, all over h. We cannot combine these yet. We need to get a least common denominator. And the only way to do that is if I multiply this on top and bottom by x plus h minus 5 over x plus h minus 5. And then we multiply this one by x minus 5 over x minus 5. And for now, we're not going to worry about multiplying these two things together. We just accept that they're the same denominator. Now, we do want to distribute on the top. And then we have a negative to worry about as well. So let's just clean that up a little bit. We should end up with x minus 5 minus parentheses x plus h minus 5 over this very funky denominator of x minus 5 times x plus h minus 5. Oops. And then all of that is over h. So can we do some things? Yeah, very much like in our last problem. Anything that does not have an h is going to cancel. The negative 5 is going to cancel with the positive 5. The negative x is going to cancel with the positive x. Sorry, a little bit of my Danish learning came out there. And then we distribute the negative to the h. So we're going to end up with negative h over this very funky denominator. And now we're going to treat this as h over 1, so we can multiply by the reciprocal, 1 over h. And here we see the h's cancel, leaving us with negative 1 over x minus 5 times x plus h minus 5. And this is our difference quotient. So these two techniques of finding the difference quotient for a quadratic equation, quadratic function, as well as for a rational function, and even a square root function, which we didn't do here, is something you're going to see in the beginning of calculus. And if you're not comfortable with it now, I don't think you're going to be comfortable with it later. Practice as much as you can now. This concludes the calculus prep assignment. Congratulations for sticking in there for a very long time of work. There's still much to be done, but I hope this provided you with confidence and the knowledge on a foundational level of how to proceed and interpret questions that you're going to encounter when you get to calculus. Best of luck.